All right, good day. Hope that you're doing well. In this video, we're going to be doing a statistic question from a previous question paper. So here we're given the following data, which are the math marks, right, out of 50 obtained by learners in class. Now, the first question wants us to determine the quartiles. Q1, which is our lower quartile, Q2, our interquartile range, Q3, which is our lower quartile. Now, first step, I'm going to try and determine my Q2, which is my interquartile range. And my interquartile range, it's the same as my median, my middle value, right? So here, I'm going to count my numbers up until I get to the middle value. So I have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. And as you could see, these are my two middle values. Because why? On the right hand side, I have 1, 2, 3, 4, 5, 6, 7 values. Same applies on the left hand side, I have 1, 2, 3, 4, 5, 6, 7 values. So my middle values are 2. And in order to get my median, I'll just add the 2, 29 plus 31 divided by 2. And this would give me my interquartile range. So punching that into my calculator, my interquartile range should be equals to 30. Now, what about Q1, your lower quartile, as well as Q3? Now, in order to find those values, Q1 simply says, or Q1 simply means that the median in the lower values. So I need to find the middle value here. All right, so if I count 1, 2, 3, 1, 2, 3, right, as you can see, 1, 2, 3, 1, 2, 3, this side. So the middle value here, it will be 21, and this would represent my lower quartile. And what about my upper quartile? I have 1, 2, 3, 1, 2, 3 here, and my 42 would be my upper quartile. Now, 2.1.5 wants us to draw a box and whisker diagram to represent the data. So first we need to draw a number line, which is up to scale. And I'm gonna use a scale of 5, 5, 10, 15, 20, 25. Remember, this should be up to scale, 30, 35, 40, 45. Now remember, on our box and whisker, we need 5 values, which is our 5-number summary. So we need the minimum value, our first quartile, our interquartile range, our third quartile, as well as the maximum value. All right, so our minimum value is at 10, and my maximum value is 48, so it will be somewhere here. Now, representing my quartiles, my Q1 is at 21, so it should be somewhere here. And my interquartile range is at 30, and my Q3 is at 42. Now drawing my box to be like this, and these should be connected to these. Right, remember your minimum value, which is at 10, your first quartile, which is at 21, your interquartile range, which is at 30, your upper quartile, which is at 42, and your maximum value, which is at 48. Now, this is how you should draw your box and whisker. Now, 2.1.3 wants us to calculate the mean and the standard deviation. Now, for the next question, we need to calculate the mean and the standard deviation. Now, remember, what is your mean? Your mean is your average, right? And how do you go about calculating your mean? You'll just simply add all your values and multiply them by the number of values you have, right? So now, I know that my mean is my average. What about how to go about calculating your standard deviation? So to calculate your standard deviation, it will be the square root of x minus your mean squared, right? The sum of these all over your number of values. Now, but first, let us try and calculate our mean. So to calculate our mean, which is our average, we said we're going to add all these values, right? So basically punching them into your calculator, 10 plus 13 plus 17 plus 21 plus 21 plus 23 plus 27 plus 29 plus 31 plus 34 plus 37 plus 38 plus 42 plus 43 plus 46 plus 48, and everything should be equals to 480. Now these values, they are 1, 2, 3, 4, 5, 6, 7. So 7 plus 7 is 14, and 15, 16. So we have 16 values. Now, 480 divided by 16 is going to give us our average, which is equals to 30. Now, we need to use this mean to calculate our standard deviation, and I'm going to do these calculations here. Now, in calculation of our standard deviation, we would need the sum of our max minus our mean all squared, right? All these values. For example, my marks, I'm going to write them here. I have 10, I have 13. I'm going to write all of them here. Now, I've written all my values here. And as I've said, I need to subtract them by my mean. So 10 minus my mean, which is 30, and this should be negative 20. And here, I need to take that answer I got, and I need to square it, right, to find the values for these columns. So same applies here. I need to take my 13 minus my mean, and whatever answer that I find here, I need to square it. So you need to do these steps for all these values. So let us go about doing that. And now, finally, I'm going to punch these values into my calculator. Negative 20 squared, which is equals to 400. So doing the same for every answer I got, negative 17 squared, which is equals to 289. So you need to do the same thing for every value. And now finally, we're going to add all these values because here we need the sum of this column right over here. So we're going to add all these values, square root them, and divide them by the number of terms we have. And now also the standard deviation formula, this square root here should cover all values. So basically square root of, right? So square root of the sum of this green column, right? Which is x minus your mean squared all over the number of values you have, right? So now basically when you add all these numbers in this green column, they should be equals to 2102. Now 2102, and all this divided by the number of values we have, which is 16. Now 2102 all over 16, our standard deviation should be 11,46. So my mean is 30 marks. Now, remember my standard deviation represents basically how many learners were closer to this mean, or basically what is the average of number of learners which were closer to this mean, right? So now 11,46, this is the mark, right? And comparing it to your mean, because always whenever you comment on the distribution, you should compare your standard deviation with your mean, your average, right? As you could see, it's not even half of our average, right? So basically I could say most learners marks were not closer to the average. Now moving on to the next table, we have 55 learners were sampled at a school tuck shop to measure their waiting time in minutes before being served. The results were published in the table below. So first we need to complete this cumulative frequency table. Let us go about doing that. So I know that my cumulative frequency for my first line is equals to my frequency, this is 6, and my last cumulative frequency should be equals to my total of 55, right? That's if I do this correctly. But 6 plus 10, right? So I'm going to go this way. 6 plus 10, it will be equals to 16. 16 plus 19, so 16 plus 19, this should be equals to 35. 35 plus 15, this should be equals to 50. And 50 plus 5, this should be equals to 55. And this would be your cumulative frequency tables. So now we need to represent the information on an Ogive. Now remember, an Ogive, it is a graph whereby we're representing our cumulative frequencies. So like now let me just try and make a rough sketch of the graph here, or let me do it here rather. So these here on my x-axis would be my intervals, right, which is the waiting time, or you could write your waiting time. And these here would represent on my x, or rather my y-axis, my cumulative frequency. Now my intervals, okay, 0, and remember this must be up to scale, right? But then I'm just trying to draw this to space 0, 4. I'm gonna put those values here, 8, and I have 12, and I have 16. So I'm using a scale of 4, 4, 8, 12, 16, 20. And now for the first interval, which is at 0 and 4, so this needs to be at 4. Okay, on my frequency, the scale that I'm going to use, I'm going to use the 10, 10, 20, 30. So the first point I'm going to plot, or the first interval, I'm going to plot at 4, right? So at 4, my cumulative frequency, as you could see, is at 6. So this would represent my starting point of my cumulative or my ogive. And for the second interval of 4 and 8, my 16, I'm going to plot it at 8. Right, so 16 is somewhere here. Now for the third interval, the 35, I'm going to plot it at 12. So my 35 is somewhere here. Now for the 12 and 16 interval, the 50, I'm going to plot it at 16. Right, so the 50 should be here. And lastly, for this last interval, the 55, I'm going to plot it at 20. So the 55 should be somewhere here. So now sketching my ogive, it would look something like this. Okay, and so I'm just trying to put it straight. Okay, so this, but it would look something like this, your ogive. And also remember, your set of x's should be up to scale, right? Now, we have done this question. Now let us see what's the other question requiring from us. Now, using your graph, estimate the number of learners who waited for more than 14 minutes. Now, you would only be able to do this only if your graph is up to scale. Right? Now, remember, mine is not up to scale, but then I'm just going to try and use my graph, which is not up to scale, to try and determine the number of learners who waited for more than 14 minutes. Now, first, I'm going to try and classify the 15 minutes, right? So the 15 minutes, it should be somewhere here. And remember, they said more than 15 minutes. So my cumulative frequency at 15 minutes, maybe if this was up to scale, it would have been at 48. So now this part of the graph, it represents the total number of learners who waited for more than 15 minutes. Now my Y value here, it's 48. And my maximum Y value, remember, it is at 55. So 55 minus 48, this would give me a total of the number of learners who waited for more than 15 minutes. And this should be equals to 7 in accordance to my graph. Remember, I'm representing this portion right over here. So approximately, right, 7 learners waited for more than the 20, or rather for more than 14 minutes.